Welcome back for the extra video. I commend you for your efforts. They will pay off later. So I'm going to reduce this to simplest form. That fraction and this fraction to simplest form. Oh my Lord, it's going to be hard. Okay, so let's get started. I noticed the number 45 over 36. 45 is half of 90. So if I drew a picture here, 1, 2, 3, 4, 5, 6, 7, 8. 45 is actually an eighth of that circle. So 45 over 360 would be the same fraction or the same decimal as 1/8. That's probably the fastest way to reduce this. Okay. Now the number 34 is actually 17 times 2. So I know that those are even. So if I divide the top and bottom by 2, I get 17 pi in the numerator and 4 in the denominator. That's my answer for my arc length for question 1. Question 1, part 2, I have the same fraction. I only want an eighth of the area, and the area is 289 pi. So if I think back, that number right there was 17 times 17 times pi. So that number is prime, and that number is prime, and they're not going to cancel. So believe it or not, that number, 289 over 8, was in simplest form for the sector area. Good job. Question number 1. Question number 2. I look at the picture, and I say to myself, 285. Well, 180 minus 285 is 105. So 105 is kind of a weird number. I'm going to subtract 45 from that. I get 60. So let me see if the decimal makes sense. So 285 divided by 360. I don't recognize that decimal. Let me do that again. 285 divided by 360. Nope. Okay, so I'm just going to have to reduce this one the old-fashioned way. So question number 2, the fraction of the circle I want to talk about is that. I know there's a 5 in both, so I'm going to divide by 5. I get the number 57. I notice that if I divide this number by 3, I get a whole number. And I know that there's a 3 in there because when I add 7 and 2, I get 9. So 57 divided by 3 is 19. 72 divided by 3 is 24. Now 19 is prime, so I'm not getting any smaller than that. So wow, okay, that's the fraction of the circle they want to talk about in question 2. So I'm talking about 19/24 of the circle, and the circumference was 18 pi, and the area was 81 pi was the whole circle. Okay, so now I'm going to try to see if I can reduce these any further. Those add up to 9. That's 6 times 3, or 2 times 9. This one's 8 times 3. I think there's definitely a 6 in both of these. So I'm going to divide the top and bottom by 6. I think that's the quickest way. So 18 divided by 6 is 3. 24 divided by 6 is 4. Yep, that's in simplest form. So 19 times 3 is 57/4 pi. This guy. This one was 9 times 9, so we know there's a 3 in there. 8 plus 1 is 3. We know there's a 3 in there. Let me see if there's a 6 in there. Nope, no 6 in there. So let's just start with that 3. We can keep going. So this is 2 times 2 times 2, and this is 3 times 3 times 3. There's no way to cancel that. So frighteningly enough, that is in simplest form. We have a fraction 270 over 360, and judging from the picture, and you can confirm it with a decimal, that's definitely 0.75 or 3/4. So 3/4 of the circumference was 30, and 3/4 of the area was 225. So reducing this fraction, I know they're both even. So if I divide this by 2 and I divide this by 2, I get 3 times 15, and 4 divided by 2 is 2. So that would be in simplest form for my arc length. This, well, I think, where did I get this from? That was 15 times 15. And 15 is 3 times 5. So another way to think about that number is 3 times 5 times 3 times 5. That's not going to cancel with that. So believe it or not, I can't simplify this anymore. So 3 times 225. That is the sector area in simplest form. Question number 4, 145. That's a weird number. That's going to be hard to reduce. This is one that's going to be a tough one, a weird one. That fraction and 38 pi was my circumference. Here's the fraction, and 361 pi was my area. So I know I'm back to just square one. I know that there's a 5 in there because when I count by 5s, I go 5, 10, 15, 20. I know that these are both even. This one, when I add together, I don't get 9, so let's just divide by 2. Old-fashioned way here. Divide by 2, because I know they're both even. So that's prime, meaning it doesn't have any factors, so that's as good as it's going to get. No other simplification possible. That's my arc length. For my sector area, I got to do the same thing. I'm going to divide by 5 on both the top and bottom, get this fraction, 29/72. Then I have that number, and I think back to how did I get that number? I got it by doing 19 times 19. So I can rewrite that if it helps to cancel this out. So those are prime. This one's prime. This thing is not prime, but there's nothing to cancel here. So believe it or not, I can't simplify that. I'm just going to take 145 times 361. Lord, that is a big number. And that is my sector area. Let me skip to an easier one. I want to look at number 8. Looking from my picture, I see that 90 over 360 is going to be a quarter. So if I take 90 over 360, I should get the fraction 0.25 because that's definitely a quarter. So a quarter of the circumference was 14 pi, and 1/4 of the area was 49 pi. So let's reduce these. Notice they're both even, so you're going to divide by 2 and get 7/2 pi. That's my arc length. I'm going to break this back open. Where did I get the 49? That was 7 times 7 times the pi, right? And this doesn't cancel, so that is in simplest form for the area of my sector. One more. I guess I'll do question number 9. It says 240/360. So nothing's looking familiar to me, but I like that I can use this method. So I can cancel those zeros like we did in class. And then I'm noticing I think I have a 3 or even a 6. Yeah, I can divide a 6 by the top and bottom. So 24 divided by 6 is 4. 36 divided by 6 is 6. So I think I could have taken a 12 out of there, but you can just keep going. 6 would reduce to 2/3. So that technically is 2/3 of the circle. Pretty cool. 240/360 is 0.6 repeating. 2/3 is 0.6 repeating. So 2/3 of 40 pi and 2/3 of 400 pi. Well, there is no 3 in there whatsoever. So this would be 80 pi/3. No, nothing in there, so that'd be 800 pi/3. Thanks for joining us. It's the arc, that's the sector.